All right, so factoring. Again, the first one here, number 16, was factoring a trinomial with a lead coefficient of 1. Now, there's a couple different ways that you can do these. There are some shortcuts. I usually try to keep the idea the same all the time. So I usually go with factoring by grouping every time. Right now, you can't factor this by grouping because there's only 3 terms. You have to first make it into 4 terms before you can factor by grouping. Yeah. So on here, this middle term, we are going to have to split. We're going to have to split that middle term of negative 10x. The way that we're going to do that is by looking at the first term and the last term. Now, oh, that changed on me before sorry, I started doing 17. Let's try that again. Still the same idea though. On this one, again, looking at that middle term first. So we need factors that are going to give us that middle term after I've multiplied the first value, the A value, which is currently a 1, and last value, which is a C value. So this is A, this is C, whoops, C, and this value is referred to as B when we're talking about a trinomial. The first thing we do is multiply A to negative 63. I find values of negative 63, since that's what I get once I multiply, that add up to that middle term. So I need factors of 63. So I have 3 and 21. We have 7 and 9. And I think that's it. Now, all these currently give me a positive value. I need a negative when I multiply. And I also need a negative in the middle. So that means the bigger of the 2 values will have to be my negative. So I'm going to put a negative sign with each of my bigger values. Now, which one of these sets adds up to negative 2? And that'd be this last one. If we combine these 2 values, those 2 B value. So that's what I'm using to split it. So it becomes x squared. And now I have 2 terms in the middle. I have a positive 7x. And I have minus 63. Now, it doesn't actually matter which one of these values you put first. So I could have also done it the opposite way. So if I either way, I will get the correct answer. Now, for the most part, I usually like to group it so that I don't have a negative sign in the middle. So if I can avoid having a negative sign here, it makes it a little bit easier. So I'm gonna go with the second option for right now. And I'm gonna group the first set of terms and the last set of terms. So now this turns into factoring by grouping. We look at the first term, we take out a GCF from that first set of terms. So I have a x squared and I have a negative 9x. What can come out of both of those? What could come out of both of these values? They both have an x, right? So I'm going to take an x out. And again, when you take it out, you're dividing it off of those previous values. So now we only have the 1x, and now we only have negative 9. In the second set, what goes into both the 7x and the negative 63? Well, 7 goes into both of those values. So I can take out 7. Leaves me with x. And then once I divide out the 7 from 63, I have negative 9. Exactly the same if I did everything correct. So now I'm taking that set of parentheses and essentially factoring that out to the front. So they come out. Other 2 values, the x and the positive 7, come together. So I have x plus, and those are my 2 factors. Now, there are some shortcuts, like on this one, since our lead coefficient is 1, we could have just looked at our C value at the beginning because anything times 1 is itself. And then the 2 values I got when I split it did end up being the values that I have in the end. That only works though if our lead coefficient's 1. So normally I just follow the same steps every single time so that we're not changing anything. So now in the next one, it's the same idea. We need to split that middle term. But before I split that middle term, I also have to look at all these values because I do have a common factor in all 3 numbers. We can take out a GCF first before we do anything else. So every single one of these every single one of these terms has a factor of what that goes into them. What value can go into 2, 10, and 48? 2. Yeah, so 2. So we're going to take that out. Leaves us with x squared. We still have a negative, and this will now be 24. So we have, again, a trinomial that needs to be factored. Well, first term now has the lead coefficient of 1. I'm doing the same steps, taking the a value, taking the c value, multiplying them together. Here's of that negative 24 that add up to the middle term. So first, let's list out some factors of 24. So we have 1 and 24, and 8, and we have 4 and 6. Now, we need a negative 24, and we need the number in the middle to be negative. So that means the bigger value has to be the negative. So for negative on all my big, which set adds up to negative 5? Well, it's going to be the 3 and the negative 8. So again, that's what I'm using to split that middle value. So this middle value becomes, I have a negative, and again, I like listing a negative value first if I can. These other two values, again, they just come down. So I have x squared, and I still have a minus 24. All we did was split the middle term. So now we can factor by grouping. We still have this one until the very end, so I'm just going to drop it down. I'm not going to do anything with it just yet. I'm going to group the first two terms and group the second two terms. What can come out of the first two terms? Well, the only thing that comes out of both of those is an x. What's left? X minus 8. In the second set, what comes out of both 3x and negative 24? Well, we can take a 3 minus 8. At this step, what's left in the parentheses should be the same. So those parentheses come out together in front as x minus 8, x plus 3. The 2 that we took out at the beginning, we have to make sure we include that in our final answer as well. So this is our all right, now we're going back to 14. So 14 was the hardest out of the 3 trinomial problems. So this time we still have to factor out a GCF. So they all have something in common. 8x to the third, 14x squared, and 6x. You can take a 2 out of every single one of those, but you can also take an x out of every single one of those. So we're taking 2x out of all 3 values squared. The middle term will now be plus 7x, and the last term will now be just plus 3. Same steps. So again, taking my a and my c value, multiplying. This time my a value is not equal to 1. So I have 4 and I have 3 that I'm multiplying. 4 times 3 gives me 12. I need factors of 12 that add, or you list them all out, that's fine too. So again, I have them all listed out here. We need it to add up to positive 7. We needed a positive number when multiplied, so both numbers are going to have to be positive. So on here, 3 and 4, those two are going to add up to 7. So that's what we're using to split that middle term. So the 7 becomes a 3x and a 4x. And it doesn't matter what order you put them in the middle. We just switch them around, and that would be fine. This 2x that we took out of the beginning, again, we're going to drop it on down, wait till the end. So now, factoring by grouping. The first 2 terms, group the last 2 terms. What comes out of the first 2? Well, just an x. What about in the second set? Do they have any common factors? Do they have any common factors? So there's always at least one common factor. In this case, it's just 1. All right. And when we're factoring by grouping, we have to take something out. So even though 1 is the only factor that goes into both of these, in order to do factor by grouping, we have to take something out of 1. Does that change any of those values? No, it's still 4x and 3. But we wouldn't be able to do the next step without taking that value out. Because now the parenthesis part is the same. So we're taking that and factoring it out by taking out 4x plus 3. The other set of parentheses will be x plus 1. Again, the 2x that we took out of the beginning. So that's our final equation, final expression, I should say. All right, the last one. This one is special because it is 2 perfect squares. So anytime we have what's called the difference of 2 squares, so we have a perfect square for the first term, we have a perfect square for the second term, and they're being subtracted. There's a pattern that we can follow to make it easier. All we have to do here is take the square root of each term and put them in 2 separate parentheses, 1 addition, 1 subtraction. And the reason why this happens is because the middle term it's not there. It canceled out. So on here, we're just taking the term from the front. We're going to take the square root of that value and the square root of the value on the back. Now, I think I got a little ahead of myself because I wrote that down before we started going over it, that we were doing the difference of two squares, but I forgot something. What did we do on the last two problems first? What was the first step that we did on the last two problems? Because we got to do it here as well. Do they have anything in common, both of those? So 27, 48. No, nothing in common. No common factors. No. Okay, they have one, but there's something else still. Think about what number is going to 27, because there's a lot less in 27 than there is 48. Think about 27 for a second. What factor is going to 27? Yeah, 1, 3, 9. That's it. You only got 3 of them. Do any of those go into 48? Yeah, 3. So we can take out that common factor, because currently is 27 a perfect square? No. But once I take it, 9 is a perfect square. And once I take the 3 out of 48, that gives me, what's that, 16? Yeah. So now that's a perfect square. So let's try this again. So we're doing the difference of two squares. These two values are perfect squared, right? So we can do what I was saying a second ago. 2 terms and our 2 sets of parentheses. One's gonna be plus, one's gonna be minus. Square that first term. So what's the square of 9? 3. And square root of x squared, x. So we got 3x. That goes into both parentheses for a front term. 16. What's the square of 16? 4. So 4 goes into both those parentheses. So it's x, 3x plus 4 and 3x minus 4. And then again, that term that we took out at the beginning, just drop in. Now, there's 4 problems there. I'm giving you 2 examples that are similar to each of those. So a total of 8 problems on the little handout that I'm going to give you today. But again, those are the types of factoring that you need to know for your exam. All right, just those. Any questions? All right, stop this and I'll pass those out.